So this video is going to be on Rolle's theorem. So we have a question that says, let f be a function defined on the closed interval -1, 1, such that f of -1 is equal to f of 1. And they want us to consider three different properties. The first one is that f is continuous on the closed interval -1, 1. The second is f is equal to cosine cubed of x. And the third is that f is equal to the absolute value of sine of pi times x. And they want to know if any of these properties on their own ensure that there exists c in the open interval -1, 1, such that f prime of c is equal to 0. So if you know about Rolle's theorem, you would know that this question is essentially asking if any of these properties give you enough information to confirm Rolle's theorem. Right, and to review Rolle's theorem, if f is 1, continuous on AB closed, 2, differentiable on AB open, and 3, the value at the endpoints is equal, then there is c in AB such that f prime of c is equal to 0. So to see the connection, just replace a and b with -1 and 1. Okay, so let's go through each of these three different properties. So 1, f is continuous on the closed interval -1, 1. That's what they tell us. And we know from the problem statement that f of -1 is equal to f of 1. Okay, so these are two different criterion of Rolle's theorem. But we're missing the third. We don't know if f is differentiable on the open interval -1, 1. We have no way of finding that out from what we're given. All we know is that it's defined on the closed interval -1, 1, the endpoints are equal, and it's continuous on the closed interval. We have no way of finding if it's differentiable. So this is not enough info to confirm Rolle's theorem. So let's look at the second property. So this one states that f of x is equal to cosine cubed of x. Alright, let's check that f of -1 is equal to f of 1. Alright, so this is the composition of an even function cosine and an odd function x cubed. And we know that the composition of an even function with an odd function is even. It's just like multiplying numbers, right? 2 times 3, 2 is even, 3 is odd, that equals 6, which is even. Function composition works the same way. So since it's even, we know that f of 1 is equal to f of -1. Alright, that might have been hard to do, just plugging in 1, because that's cosine cubed of 1 radian. That's kind of hard to figure out. Alright, so f of 1 is equal to f of -1. Now we need to check if it's continuous. Alright, so cosine cubed of x, there's no problems with this function. There's no kinks, there's no holes, there's no discontinuities. Alright, so f is continuous on the closed interval -1 to 1, and f is differentiable on the open interval. And the reason for that, well, we can just take the derivative, right? F prime of x is 3 cosine squared of x times negative sine x. That's using the chain rule, right? Alright, so these three criteria of Rolle's theorem hold. Okay, so property 2, we went through and we showed that Rolle's theorem applies. So the question doesn't ask for it, but what is that value c, such that f prime of c is equal to 0? Well, we've got f prime here. In order for f prime to be 0, one of these two factors has to be 0. Right? So you might say cosine of pi over 2 is equal to 0, but pi over 2 is outside of the interval. So let's look at sine. Well, that's just sine of x. We know that sine of 0 is equal to 0. Alright, so these three criteria tell us that, there exists a c in negative 1, 1, such that f prime of c is equal to 0, and that value of c is equal to 0. So let's check out the third property. F of x is equal to the absolute value of sine of pi times x. So the easiest way to check this one, in my opinion, is to graph it. And to graph it, let's first graph sine of pi x, and then we'll graph the absolute value. Okay, so we're on the interval negative 1 to 1. So at 1, sine of pi, that's 0. At 1/2, sine of pi over 2 is 1. Okay, and you can see where we're going. So it looks like this. And then when you take the absolute value, the negative portion becomes positive. Okay, so it looks like this. Alright, so now it's evident that there is a kink in this graph at x equals 0. It looks like the derivative does not exist there. And, this is probably enough for this problem. If you want to confirm that, then write it out as a piecewise function. So it's positive sine of pi x when x is larger than 0, and it's a negative sine of pi x, say when x is less equal than 0. And then we can take the derivative. Using the chain rule, that's going to be pi cosine of pi x. And it's going to be negative pi cosine of pi x for x less than 0. We can't say what it is at x equals 0, because if you took the limit as x approaches 0 from the right, it would tell you that the derivative was pi, and if you took the limit as x approaches 0 from the left, it would tell you that the derivative was negative pi. So if you zoomed in, it would look like this, right? Where this derivative was pi, and this was negative pi. Alright, so since there's this kink in the graph, and this is on the interval negative 1, 1, that means that the function is not differentiable on the open interval negative 1, 1. And that's a key criterion of Rolle's theorem. So for property 3, we cannot make this conclusion. So the only property by itself that we can make this conclusion for was property 2.